Hello, my dear students. Welcome to our program for science, third prep stage. Today is the first day for our curriculum in the first term in this year. We have many lessons for you. We have many information for you. So we have many things to do or to make studying for your lesson very good. Let's start our lesson today, the first lesson of our curriculum in this term. Let's start. We have Unit 1, Lesson 1, we have speed. So, the meaning of speed. What's meant by speed? What's meant by this concept? And what are the types of speed? How can we make this graph and how can we calculate the speed of anybody? So, we have first of all, we have the speed is the measure of how far an object that moves in give time. So, again, the speed is a measure. It's the meaning of speed in English. So we have this is the measure of how far an object move in a given time. So we have a time. So we have a measure here. So we have the measure how this one. How far it means what? It means the distance that covered by the body to change its place from point to another. So we have a definition of speed. This the definition. It's what? It's the change of distance in unit time. Again, we have the speed. It is the change of distance in unit time. What's meant by distance? What's meant by unit time? So we have the distance. It's the pass or actual pass of the body here, like this car. It moves from a starting point to the end point. From what? From the home, from our home to the school, or from school to any building like this in the street. So it covers a distance. So it's what? The distance in unit time, it means it's covered a distance in 1 second, 1 hour, or 1 month, 1 week, anything like this, 1 minute, for example. So here, for last time, we have the speed. Speed is the change of distance in unit time. What's meant by this? We have this speed. Speed here, we have a rule to calculate this speed. Speed again, it means V. What's meant by V? It's the symbol of speed. Equal what? Equal delta D. It means change of distance. Divide. Divide what? Divide delta T. It means that change in time. So here, change of distance of this body to move from starting point to the end point. And we have the measuring unit. It means distance. It's measured by meter. And we have time is measured by second. So here the second or an hour or a minute, it's the unit or measuring unit of the time in this unit. Or in science we have the second, it's the measuring unit of time, the smallest one here. Okay, so here we have the speed. Speed equal again V equal delta D divide delta T, where what? The V is a speed, D is a distance in meter, measured in meter, and we have time, it's in seconds. So here this is the concepts that found in the concept of speed. It contains what? Contains many concepts like V, it means speed, distance and time. Without any one of them we have no speed. If I have the car like this that move from point to another, so it moves the distance. And we have this distance is covered. It must covered in a time, in a short time, long time, anyone in any case. So after that, we have the speed rule. What's meant by speed rule? Speed rule here, it means I need to know the rule or the basis of this rule to calculate the speed of anybody. Like what? We have formula triangle. So the formula triangle, it means what? Here we have what? We have S, symbolized by speed, and we have T, it's like time, and we have distance here, it's symbolized by D. So here we have divide and divide. What's meant by this? If I need to calculate, this is the magic triangle. If I need to calculate S, it means the speed. So I put my hand like this, okay, to cover the S. So S, it means what? D divide T. And we have another one. If I have or I need to calculate d, so I cover d. So it means what? S times t. It means speed times time. So the distance equal speed times time. Why? Because I cover d, I need to calculate distance. So distance is measured by the time or by meter, and we have d equal s times t. So after that we have t. T, it means what? It means the time. I need to calculate our time. So d divide what? Divide s. So here this is time equal distance divide speed. So this is what? This is 3 rules that we use it to calculate any one of these concepts like this. We have d or s or t. So we have another thing like this. We have t again for last time. T equal d divide s. After that, we have calculating the speed problem. We have a problem to apply this rule. A car travels at 25 meters per second for 3 minutes. How far does it travel? So calculate the distance. I need to calculate this distance. The car travels 25 meters. For what? For 3 minutes. Or it had the speed 25 meters per second for 3 minutes. What's meant by this? Calculate the distance. So here we have calculating the distance here. It's like this. So here this one, we have v equal delta d divide delta t. And we have distance from the rule before. We have distance equal v times t. So the distance equal speed times time. So we have the speed here. It's 25 meters per second. And we have 3 minutes. So what's meant by 3 minutes? 3 minutes, it must change into what? Into seconds, right? Why? Because I need to make the measuring unit of time, it's the same in 2 parts of this problem. So here we have v equal delta d divide delta t, and we have d, it's equal v times t. What's about v? It's equal 25. And we have times what? Times 180. What's meant by this? Is 3 minutes. 3 minutes times what? Times 60. To change minutes to what? To seconds. So here we have 4,500 meters. It is equal what? Equals 4.5 kilometer. So here this is one problem to apply the rule of the speed. After that we have another part about this part. About what? About the speed. So how can we determine the speed? Determination of speed. So here we have a symbol like S. It means speed. Or we have V. It means speed also. Why? Because we have the reference of S. It's our book. So we have V. It's what? It's symbol for or symbol of what? Of the speed. And we have, this is the symbol of velocity. It is another type of speed. So here we have the speed again. In last time we have 2 concepts that related to speed. We have time and we have distance. So after that we have, how can you determine the speed? How can you measure the speed of our car? For example, let's go to start this activity. So here the determination of speed. How can speed be represented? So here we have this part like this. It's a play. Play for what? We have in this picture, we have a car and we have a driver, and another thing, we have this car that move on the street. So after that I make what? I make or I press play to see what's happening here. So here we have the speedometer. What's meant by speedometer here? It means that the device that measure the speed of our car. It changes from 20 to 40 to 60 to 80 to 100 to 120. And in this counter we have time. For example, we have 20 and we have 34 meters, and we have 25 and 484 meters, and so on. So we have different speed, different distance in different periods of time, or different time intervals. So we have time intervals. It means what? It means periods of time. And after some time, after the speed, the speedometer move again to what? To 0. Why? It decrease the speed to stop. So we have here two parts of this activity. We have the speedometer increase the distance during time to find out increasing speed, and we have after a period of time it moves again to what? It moves again to zero. Why? Or to stop. Zero, it means to stop or to rest point. So we have the time and distance here. They are what? They are different in each one of these parts of the activity. So we have next here, we have the table here that contain all numbers or all distance that covered by what? By the car in all periods of time. How can speed be represented? So the data can be recorded and shown in the table, so the data can also be shown in the graph. So we have the graph here, and we will talk about graph in lesson 2 after this lesson. So we have what? An advantage of this. So this advantage, it means what? I need to make the graph like this. The car moves from 0 and increase 5 seconds to reach what? To reach the 1 meter or 2 meters. After that we have 10, it's 100, and we have 15, it's 200. 20 seconds, that covers what? Covers about 300 meters and so on. So we have the graph like this. The meaning of graph, it's two parts or a relation between what? Between distance and time to represent. How can speed be represented? To represent the speed, and the parts of each one or each part of this graph represent a type of speed that we talk about it after a period of time. After that, we have another one or another thing about this graph. So how does the distance time graph show? Show what? Show the relation between the distance and time. So we have play here to find out the parts here of this graph. In this one, we have curved slope, object moving at non-uniform speed. What's meant by this? We will talk about it. Straight slope equal the object moving at uniform speed. It's the opposite of non-uniform, yes. So we have no slope here object, so it is stationary. Stationary, it means at rest point. It's 0 point without moving. It's in the stopping or the rest case. So here the curved slope object, we have non-uniform speed and we have uniform speed and stationary case. It means what? It means the body at rest in this part. So we have many graphs that represent this one. So here we have many parts like this here, and we have many types of speed that represented by this part. The types of speed. The first one, or first of all of these types, this is uniform speed. What's meant by uniform? Uniform, it means one shape, one color. Between us in our school we have uniform. So uniform in our school, it means what? It means the t-shirt, trousers that had the same shape, same color, and all of us that wear this one. So it's called uniform. And here we have uniform speed. It means they are equal each other. What are things that equal each other? It's equal distances are covered by moving body in equal time intervals. So the periods of time. Time intervals, it means periods of time. Don't forget this. So we have uniform speed. We have two expressions here. Equal distance and equal time intervals. We see this one like this. We have this one, or non-uniform speed, the opposite of the first one. So its unequal distances are covered by moving body in unequal time intervals or periods of time. So non-uniform speed, it means unequal. It's not equal each other. We have many cases here that distance are not equal or time intervals are not equal, and the other one it's equal each other. And we have the third case, both of them are not equal to each other. Okay, so we have an example to illustrate this one. We have a car here, and this car, we have a driver, and it moves in the street. So like this, it moves a distance. So we have the first distance here like this, from the rest point to the middle of the street, and we have another distance like this. So this another distance here that covered by this one, every time or every distance is 10 meters in 1 second. So every time or every part 10 meter in 1 second. So it is equal each other. 10 meter here in the first distance and 10 meter in the second one. We have 1 second in the first period of time, and we have the second one 1 second in the second period of time. So we have the car moves through equal distances in 2 equal time intervals. So I need to calculate the speed. So it is 10 meter in 1 second. So it is 10 meter per second like this. And after that, we have another type of speed. We have irregular speed and average speed. It is irregular speed. It means what? It means the non-uniform. It's like this. So irregular or regular speed. So here irregular speed and average speed, the third part or the third type of speed. It's hard to measure the regular speed practically. Why? Due to the presence of traffic jams and traffic lights in the street. So we have many things that make our speed or uniform speed. It is not really or not actual one. So it's hard to measure the regular speed. Why? We have a question here. Give reason. It's hard to measure the regular speed or uniform speed practically. Why? Due to the presence of what? Of traffic jams or traffic lights in the street. So after that, we have these traffic jams here. Can you move in this one or this street by the same distance in the same time intervals? It's impossible. Why? Because we have many objects that found in our street. So we calculate the average speed. Average, it means what? It means all distances that covered by the body, or all distance that covered by the car in what? In all time intervals. So here we calculate the average speed to know the total distances that covered by the whole time or all the time intervals of the trip. So the average speed equal what? Equal total distance traveled divide total time taken. So after that, we have an example. We have our street and we have our car. This is the toy car that move by remote control, for example. So it moves what? It moves at first distance like this, and we have the second distance like this. But we have the first distance, it's what? 10 meter in 1 second, and we have 20 meter in 3 seconds. So here we have this one. This one is what? Is different speed, different types of speed, or it's called irregular. It's irregular. It means what? It means 10. In the first part, we have 10 divide 1. It means 10 meter per second. And we have the second one is 20 divide 3, or 20 divide 2, or 20 divide anything like this, 20 divide 4. So it is 5 meter per second, for example. So we have different parts or different speed in any time intervals. Must be different in one of them or different in both of them. So here the car moves two unequal distances in two unequal time intervals. So here this is an example for what? For a regular speed or non-uniform speed. So I need to calculate the average speed. I take the total of these distances, divide total of the time intervals. 10 and 20, it's 30. 1 second and 3 seconds, it's 4 seconds. So we have what? We have 30 divide 4 and try to answer it. So here, this is another part about this one. We have number 4, another type of speed that called relative speed. What's meant by relative speed? Relative speed here. Relative, it means what? It means we have two bodies that move, or one of them move and the other one doesn't move. So here we have two buses here, like our bus in the school. So the relative speed, it makes what? We have relative, I need to calculate the speed of our car, for example, to another car or related to other car. So it moves like this. For example, in our street, we have many cars that move with each other in the same second, in the same distance, in the same period of time. So we have these two cars. It means what? 20 kilometers per hour. So it means 20 kilometers cover in 1 hour. So 20 kilometers each one of them in 1 hour. So they are equal each other, and they move in the same direction from the same point, from the same starting point to the end point. So we have relative speed is like this. if two cars move in the street in the same speed and the same direction, they appear as constant cars for each other. Again, it's very important to know this. We have two cars moved in the street in the same direction with the same speed, so they are appear to us. If I ride the first bus and I see the second bus, so we have here this bus here, it means what? It means it's related to me. So I can see the second bus. In this case, it is the same. It's like constant. It doesn't move for me, but for other cars, it moves. So we have another one. So the speed here, it means V2 or V1 minus V2 equals 0. Why? 20 minus 20 equals 0. So the relative speed in this case equals 0 because we have two cars or two bodies that move in the same direction with the same speed. Another case of this relative speed, we have two cars or two buses like this that move with a different speed in different time intervals, and we have different distance in different time intervals. And here we have this relative speed like this, one of them that move faster than the other one, but they are in the same direction. So here we have 20 kilometers per hour for the first one, the faster, and we have 10 kilometers per hour, the second one. So here the relative speed, the first one that related to the second one, so the first one here, it's what? It's related to the second one as faster or what? Or slower. According to what? According to which one relative to the other one. So here we have this one, it's 10 kilometers per hour. And here we have V1 minus V2 equal 10. 20 minus 10 equal 10. Why we have minus here? Because they move in the same direction. Don't forget this one. This information is very important. If I have two bodies that move in the same direction, so we have minus or negative. The first one, V1 minus V2 equal 10. And here we have the rule. If two cars moves in the street with a different speed and the same direction, in the same direction, so the first car appears more faster than the second car. It's a rule of this one. Another case, if I have relative speed also between two cars like this, and we have here the first one and the second one here, they are opposite in direction. So here this is the opposite direction like this. It moves with the same speed or different speed, so we have plus or summation of each one of them like this. It moves in the opposite direction in the same time, so they appear. One appears to the second one or any one of them that's faster than the first car. So we have 10 kilometers per hour and 20 kilometers per hour in opposite direction, so we have the total of them. V1 plus V2 equal 30 kilometers per hour. 30 kilometers per hour, it means what? It means if the two cars in the street in a different direction, different speed, different direction, the first car appears more faster than the second car in all cases in these parts. So this is about relative speed. And relative speed, it has no graph. And we have the graph for what? For body at rest. Remember this from the first activity. The body at rest or uniform speed, non-uniform speed. So after that, we have an example about this. So we have the example here. About what? About the speed and the types of a speed. A runner covered a distance of 100 meters of the straight track in 10 seconds. Then he returned back walking. We have running and walking. He took 80 seconds to return back to the rest point. Complete the following. Number one, we have his average speed while running. It's what? V equal del D divide T, 100 divide 10 equal 10 meters per second. And we have his average speed during returning back equal what? Equal the D divide T also. We have what? We have here 100 divide 80 equal 1.25 meters per second. Dear friends, I hope to enjoy your time with us. We have many information about this, about the speed, about the types of speed, and we have many problems to calculate it or to answer it in your book in this lesson. Try to answer it and try to study this lesson very well. It's very important for you, and we have another part about speed and this concept in another session. Till we meet again in another session about science, third purpose stage. Till we meet again, thank you and goodbye everybody.